You ever see one of those headlines about a new program that promises these amazing results, and you just kind of think, yeah, right, does that actually work? How can we be sure? Well, today, we're going to pull back the curtain on research design to find out how the experts separate what's real from what's just wishful thinking. Okay, let's jump right in with a real-world example. Imagine there's this new workshop, and it's designed to help teens cut down on their screen time. A few weeks go by, and bam, their phone usage drops. That's a success, right? Well, maybe. But hold on, what if their usage dropped because it was finals week? Or what if a huge social media app had a massive outage for a week? How do we prove it was the workshop and not something else? That is the exact puzzle we're here to solve. So here's how we're going to break it all down. First, we'll cover the basic rules of cause and effect. Then, we'll learn to spot the saboteurs that can mess up our results. After that, we'll look at the different research designs you can choose, talk about whether something that works in a study will work in the real world, and finally wrap up with why all of this matters so much. Let's do it. All right, let's get down to the absolute bedrock of all of this. If you want to say that something works, you have to prove it caused a certain result. But what does that actually take? It all boils down to this one big idea, causality. Now, this isn't just about two things happening at the same time. It's about proving that one thing, the cause, is the direct reason the other thing, the effect, happened. Seriously, the whole entire goal of a good research design is to build a rock-solid, undeniable case for causality. So in the world of research, we've got special names for these things. The cause, that's called the independent variable. Just think of it as the thing we change or introduce, in our case, the smartphone workshop. The effect is called the dependent variable, because what happens to it depends on the cause. For us, that's the change in smartphone use we're hoping to measure. And to prove this relationship, researchers have three golden rules. Think of it like a three-point checklist. First, covariation. This just means the two things have to change together. When the program starts, phone usage goes down. They're connected. Second, temporal precedence. This one sounds fancy, but it's super simple. The cause has to happen before the effect. The workshop has to come first, then the phone use drops. And third, and this is the really tough one, you have to rule out every other possible explanation. All of them. The exams, the app outages, everything. And all of this leads us to a really important term, internal validity. The best way to think about this is like a confidence score for our study. If you have high internal validity, it means you're super confident that your program, and nothing else, caused the change you saw. Low internal validity, on the other hand, means your conclusion is pretty shaky, and something else could easily be the real cause. So, if internal validity is our confidence level, what knocks it down? Well, let's meet the saboteurs. These are the common culprits that can sneak into a study and totally undermine its validity, making it look like our program worked when it might not have had it all. Let's run through a few of the usual suspects. First up, historical events. That's our social media outage, something that happens out in the world that affects our results. Then you've got maturation. People just change over time. Maybe the teens in our study just naturally grew out of being on their phones so much. A huge one is selection bias. What if the teens who signed up for our workshop were already the most motivated to change? That would totally skew the results. And finally, there's the testing effect. Sometimes just the act of measuring something changes it. Think about it. That first survey asking them about their phone habits might have made them self-conscious, and that awareness could be the real reason for the change. Okay, so we know the rules, and we've spotted the enemies. How do we actually fight back? Well, this is where the researcher's toolkit comes into play. Different research designs are basically different strategies for protecting our study and getting to the truth. Designs basically come in three main families, and the big difference between them comes down to two key ingredients: having a control group, that's a group that doesn't get the program, and using random assignment to decide who's in which group. At the very top, you have the gold standard, true experimental designs. They use both, which gives them the highest possible confidence, the highest internal validity. In the middle, you've got quasi-experimental designs. These are really common in the real world because you can't always randomly assign people, like students who are already in different classrooms. The results are pretty good, but not quite as airtight. And down at the bottom are pre-experimental designs. They have neither, which makes their conclusions, well, pretty weak. But what if you're not working with a big group? What if you're just focused on one person or maybe one school? For that, there's a specialized tool called a single case design. It's actually incredibly simple, but so powerful. First, you have what's called the A phase, or the baseline. You just watch and measure the behavior before you do anything. Then you introduce your program. That's the B phase, the intervention, and you keep measuring to see if anything changes. So let's picture this with just one student. During phase A, the baseline, we're just observing. We're not doing anything yet, just tracking how many times a day they check their smartphone. And as you can see, that number is pretty high. This is our starting point.
And then we introduce our intervention. This is phase B. Maybe we give the students some new strategies or coaching. We keep measuring and wow, look at that. The number of phone checks absolutely plummets. Seeing that sharp, dramatic drop from A to B gives us really powerful evidence that our program actually worked for this specific person.
So great. We figured out how to be confident that our program worked in our specific study with our specific people. But that just opens up an even bigger, more important question. Is it going to work for anybody else? I mean, this is the real million-dollar question for any researcher or policymaker, right? It is fantastic that our workshop helped the 50 teens in our study, but does that mean we should roll this out across the entire country? Can we generalize these results? This brings us to our second huge concept, external validity. Here's the best way to think about it. Internal validity asks, did my recipe work in my kitchen, with my oven and my ingredients? But external validity asks, will this recipe work in anyone's kitchen, anywhere in the world? You could have a study with perfect internal validity, a flawless recipe in your own kitchen that has zero relevance to the real world because the conditions were just too unique. And you guessed it, just like with internal validity, this one has its own set of threats. Your sample of people could be unrepresentative. For example, volunteers who sign up for a study are often way more motivated than the average person. The setting itself can also be a problem. People often act differently when they know they're part of an experiment. We call this a reactive setting. So how do we build that real-world confidence? What's the solution? Well, the answer is one of the most important concepts in all of science, replication. You do the study again and again, but this time with different people, in different cities, under slightly different conditions. And if you keep getting the same basic results over and over, then your confidence that you found something real, something that truly works, just goes through the roof. Okay, we have covered a ton of ground here, from causality and control groups to internal and external validity. But let's bring it all home and talk about why understanding this stuff is so incredibly important for all of us, not just people in a lab coat. Because at the end of the day, that's what this is all about. Good research design isn't just some dusty academic exercise. It's the foundation for making smart decisions. It's how we move from saying, I think this might work, to we have strong evidence this will work. It's how we make sure we're spending our time, our money, and our energy on solutions that create real positive change in people's lives.
So I'll leave you with this. The next time you read a headline or hear about some breakthrough study that promises the world, you now have the tools to dig a little deeper. You can ask those critical questions. Who was actually in the study? Was there a control group? Could something else, anything else, explain these results? Just being able to ask these questions makes you a much smarter, much more critical consumer of information. Thanks for tuning in.